So the next topic is also a new topic for you in wave section, that is related to wave intensity. In last class we discussed that about the polarization, right? That to increase the intensity of the light because of that polarization process. And in this concept we are going to study about that on which factors and how to calculate the intensity, right? Basically, if we consider waves, so basically waves are going to transfer only energy, not matter, right? That is a basic concept of the wave that we already studied. Okay. So since we are transferring energy in waves, so the definition of wave intensity will be like the amount of energy passing through unit area per unit time is the intensity of the wave, right? So basically, when we are going to find the amount of energy, so basically the amount of energy passing through a unit area per unit time is the intensity of wave, because waves are going to transfer energy only, not going to transfer matter. Okay, any confusion?
No, no confusion.
Okay, so basically, the most important thing is this definition is per unit area and per unit time. First of all, if we just consider energy per unit time, so if we divide energy per unit time or work done per unit time, so the rate of change of work done, or we can say that the amount of transfer of energy per unit time is equals to what? If you remember, we studied the definition, rate of doing is equal to what, from the work energy power section. So rate of doing work is known as power, right?
Yeah, so it's like measured in watts.
Yes, so that is the same concept goes over here, the energy passing through a unit area, then per unit time. So the formula will be like this. Like if I write intensity, so the very first thing in the definition is energy passing through a unit per unit time. So basically energy over time, then
Wait,
again unit time.
I is intensity?
I is intensity, E over T is, okay, let me write it.
That's E over T is the power, and then power divided by time.
Yes. Basically, energy passing through a unit area, right? So area is a specific, the amount of area through which it is going to be passed through, then per unit time. So the final formula will be like I is equals to P over A, right? So basically, P is derived from the rate of doing work or the rate of change of energy, right? So in simple word, we can say that the ratio between the power or area, or we can say that the power generated by a wave per unit area is known as intensity.
Okay.
So this is a very basic definition for wave intensity. All factors are already known over here. This is intensity of light. Okay, after that, we first consider the conceptual definition, and after that we have formula. So according to formula, we can also write it as intensity is equal to the power per unit area in simple words, right?
Yeah.
Okay, now one more thing, it is also, there is also a concept of direction. Let's suppose uh, if we consider the area, so basically the area through which waves are going to pass through, so it is always perpendicular to the direction of velocity. The point is the area that wave passes through is perpendicular. For perpendicular, the direction of velocity. What is the, are you getting it? Let's suppose
Um,
waves are moving in forward direction.
yeah, so the area also has to be like in forward direction. Like
Yes.
it can't.
Yes. So you got the concept, right?
Yeah.
Just like a filling of water in a bucket. So the surface area is in different form and water is flowing in different direction. So both are in perpendicular direction, right? And one more thing, this is our first basic equation, and two other important factors are also included for intensity. And those two important factors are, the first one is that intensity is also directly proportional to what? The square of amplitude, right? This A actually represents you amplitude. So if you want to increase the intensity, so your amplitude will also increase. So both are directly proportional, right?
But more specifically, it's like proportional to the square of
Square of it,
amplitude.
yes. And secondly, the
Wait,
intensity,
so the A in the proportional one is amplitude, but the one in the formula for intensity, that's
that
gonna
is
be
area. Yes, yes,
different.
yes. And this F represents frequency, because these A and F are the factor that increase or decrease the frequency, right? And this A basically for the definition of intensity, right? And these are the
Yeah.
factors. So identify them when they are talking about the factors. So we know that we are talking about the amplitude, and when we are talking about only a specific basic definition, so we know that it is related to the area, right? So in
Yep.
intensity is directly proportional to square of frequency and amplitude. So you may write by yourself because that is not a big deal. So let's suppose if we increase the frequency or amplitude 2 times, so your intensity will be increased by 4 times.
I already wrote everything down.
Yes. Okay. Let's suppose if we are having spherical waves, so what will happen then? Because this is only related to the perpendicular shape, right? Let's suppose
Yeah.
if we are having spherical waves.
Like the ones when the ripples happen, like it happens in the sphere.
Yes, I will show you that what we talk about. If we talk about the spherical wave, so basically spherical wave is it is spreading equally in all direction. Just like if we start from a single point, let's suppose if we just start from this single point, so we are going to spread in all direction equally. And how it actually happens? It actually happens like this: that from this point we are going to expand in this direction. We are also going to expand in all directions. I'm only drawing some journal points, so that will give you the concept that how the intensity is to be graphically or in the diagram form.
So it's like the same radius from the main point.
So the waveform, or we can say that the circular wave or the spherical waveform will be like this, that we combine these 2 points and then move down, combine these points. So this will be like a 3D form. I hope you are getting
Oh, yeah, I get it.
like this. So basically these are a waveform like in Z axis or in 3D form. So initially, let's suppose if initially we consider this one as A, let's suppose this is A, the area single. So it is going to be spread again, and it is going to be spread like this, that this area will be like this, right?
Yeah.
And simply it goes like increasing because we are having a sphere form, right?
Yep.
And if we want to write the formula for the intensity of surface of a sphere, so the intensity of the spherical waves or the surface of a sphere will be like P over P is same the power divided by, because initially we are having a linear form, so that is area, but now we are having a spherical. So you know that for spherical, what is the value of area of a sphere? 4 pi r square, right?
Yeah.
So 4 pi r square. So this is the formula for the spherical waves or the spherical surface. So let's suppose they are not going to ask more about this sphere form. They mostly ask about the linear, because this topic is already new for you, right? If you studied the linear first, so then they will mostly ask about the spherical. But just for the basic reference, that this is will be important, that let's suppose if they ask about the formula or the equation or the relation for a spherical wave, so you need to know about the formula. And that is not a big deal, because we do in mathematics also that volume and the area of all other shapes and the diagrams are different, not equal, right?
Yep.
Okay. And we know that power and 4 pi are a constant type value, because the energy passing is constant. So power over 4 pi like a constant term. So we are only depending upon the distance, that how far we are from the source, right? Let's suppose if we consider this formula, I is equals to P over 4 pi into 1 over r square. So basically this power over 4 pi are like constant terms, because once we are going to use a light or anything which is going to be generate source, so power will be constant, right? Because we are using a same source. But if we change the distance from the source, right? Let's suppose if we are standing at 2 meter from the source, and if we are standing from 4 meter from the source, so distance basically is a variable factor over here, right? So that is
Yeah.
I is inversely proportional, or I is directly proportional to 1 over r square, right? Because most of the
Yes.
time they used to ask about the inverse square law of intensity. So basically, whenever we are using the terms like this 1 over r square, 1 over anything square, so that gives you the concept of inverse square law, because we are having inverse relation, then we are having a square on it. So that's why it is known as inverse square law. Any confusion?
No, no confusion.
Okay, it
So this
means
is also part of spherical, like
yes,
you just this is also part of the spherical waves.
yes. We are only talking about spherical, right? Because for linear one, we already discussed the factors. This is only for the spherical, right? So let's suppose if they ask about what is the inverse law, or what is the relation for the inverse law for intensity of a sphere. So you use this equation, right? I is
Yeah.
equal to 1 over r square. And there is also a very common thing, that if we increase the source, or let's suppose when source is twice far away from any object or anything, so your intensity will be 4 times less, because we are using I over r square. So let's suppose if the r is 2 times, it means we are 2 times away, or like distance is 2 times increasing from the initial point, so your intensity will be decreased by 4 times according to the law, right? Because we
Okay.
write I is equals to 1 over 2 square, and that is equal to intensity decrease times,
Got it.
right? So these are the type of things which is included in your inverse law application. Any confusion till now?
No, it's all clear.
Okay.